Зараз ми переходимо до доповіді від Себастьяна Бергмана, від того, хто створив PHPUnit і є основним його мейнтейнером на сьогодні. Тож я переходжу на англійську мову. З нами Себастьян буде вести свою доповідь теж англійською мовою. So Sebastian Bergmann, the creator of PHPUnit, he will tell about how the tests can always be better, about how to optimize their performance, the organizational structure of the tests, and provide better feedback when the tests fail. In this talk, we'll get more information about how to build a reliable test suite that will not fail every time you update your code, and how to maintain the tests overall. So, as always, I suggest you to join our Discord chat in track A and ask questions for Sebastian. I will read them at the end of the talk, and we will discuss them with Sebastian Bergmann. So, Sebastian, welcome to PHP Fwdays.
Hi, my name is Sebastian. I'm doing things with computers since 1990, PHP since 1998. 21 years ago, I started to work on PHPUnit. And in 2009, I co-founded the PHP consulting company together with Arne Blankertz and Stefan Priebsch. A while ago, before the pandemic hit, I asked the internet, what topics would you expect to be covered in a conference presentation titled Optimizing Your Test Suite? And these are just some of the keywords that were used in replies to my questions. Faster, better feedback, easier to maintain, organizational structure, and readability. So what did I do with those keywords? Well, I put them into an abstract for a presentation, and welcome to that presentation, Optimizing Your Test Suite, right now. Your tests can always be better. They could be faster to execute. They could provide better feedback when they fail. They could be easier to maintain. In this presentation, you will learn how to optimize your PHPUnit test suite in the dimensions of efficacy and efficiency, as well as readability and organizational structure. If you are like me, you would be inclined to say bingo right now, because buzzword bingo. But bear with me, I really hope that this presentation will be useful beyond the marketing blah blah of an abstract like that. For this presentation, I have the following guiding questions. How can we write readable test code? How can we implement maintainable tests? How can we get better feedback from our tests? How should we organize our tests? And last but not least, how can we efficiently run our tests? Let's start with some principles. For instance, there is something called the first properties of unit tests, and you may have guessed it already. First is an acronym. Tests should be fast. They should be isolated. They should be repeatable. They should be self-validating, and they should be timely. Fast should be obvious. I want to be able to run my tests. That should be quick. Each individual test should be really, really quick to execute so that I have a really short feedback loop while I am working on something. Isolated means I do not want one test to fail because some other test has failed and made a mess of our environment. If a test fails, the reason for that test failing must only be in that test and the code called from that test, and not because something else has happened. Tests should be repeatable, meaning if a test succeeds, I can run it 1,000 times and it should pass 1,000 times. There should not be that one random event that makes the test fail in 1 out of 1,000 times. The test should be self-validating. That was a huge step forward a couple of decades ago when we got the first test frameworks that offered self-validating tests. Self-validating means you can run a test and you do not, as a human, need to look at the outcome, evaluate the outcome, and make a decision. Yes, this is what I expected, the test has passed. No, this is not what I expected, this test has failed. The test should have the information not only how to perform the test, but also how to validate it, so that you do not need to do that. That should be automated. And of course, timely test. The entire thing makes no sense, at least in my opinion, if you write the tests a long time after you originally wrote the code that they verify. Ideally, tests are implemented around the time the code is written, even more ideally before the code is written. That would lead us to test-driven development, but that would be a topic for another presentation. There's a different spin, if you will, that you can put on the isolated. You can use the I also for independent, but the principle stands. It means the same thing. It's just a different word that fills the I. Another principle, the triple A of testing, arrange, act, and assert. Each test method should group these functional sections separated by blank lines. And yes, this to some degree gives us a coding guideline with regards to formatting our test code. Arrange all necessary preconditions and inputs. Act on the object or method under test. And finally, assert that the expected results have occurred. And by the way, if you do not know what c2.com is, I would invite you to go visit that website. Wiki.c2.com is the oldest wiki. It's the first wiki. It was created by the person who invented the wiki, Ward Cunningham. And it is a really interesting place because it was there that principles like arrange, act, and assert, but also things like design patterns were first discussed by the people that later wrote the books and so on. And some of the discussions that led to principles like arrange, act, assert, and design patterns can still be looked up there and followed there. And for historical reasons, and if you're curious in why and where those principles come from, that's really a treasure trove of information. So arrange, act, and assert, what does that look like in practice? This is more of the examples that come later in this presentation. This example is from a hobby project of mine that is available on GitHub. A while ago, I picked up a book where a ray tracer is implemented using test-driven design, test-driven development, and I'm following along the chapters of that book and implement a ray tracer in PHP because that's fun. I used to do 3D real-time graphics, not ray tracing, but real-time graphics when I got started in programming a long time ago on the Amiga in the demo scene. But so, like I said, that's a hobby project, that's a fun project, but also it is a project, and that will become important later in the presentation. It's a project where I experiment with new features of PHPUnit. So if you're interested in the code, go to GitHub, look up for my ray tracer project, and you can look at the examples in more detail. So this is a rather typical unit test that follows the arrange, act, assert pattern. We're testing that a vector can be added to a point. We start by creating our point and our vector. That is the arrange phase. Then we perform the addition of the point and the vector. And then we assert the outcome. That's it. Arrange, act, assert. We set up our fixture. We create the state of the world that we need. Arrange. Then we perform the action that we want to test. Act. Then we assert the outcome using assertions such as assert same that are provided by our test framework PHPUnit. There is an exception to the arrange, act, assert when it comes to testing exceptions, because exceptions are exceptional, unincluded, pun intended. Arrange, expect, act is what we do in that case. We arrange. Then we tell the test framework that we expect an exception to be raised by the next step, by the act. We act, we hopefully trigger the exception that we're interested in, and the test will be marked as a success because this is the exception that we were expecting. If we get a different exception, or if we do not get an exception at all, then that test fails. Of course, there is also a different interpretation of the AAA of testing, which just uses slightly different wording in the form of assemble, activate, assert. All test cases assemble the data resources they intend to use, then they activate a target method, and then they assert that some side effect from that method is within tolerance. Again, that is quoting from the first wiki. We're still talking about principles, and another principle that not only is relevant when it comes to testing and test code and maintaining test code and writing maintainable test code, but also, and probably even more importantly, when it comes to writing the production code, the code that you test, is the principle of dry. Don't repeat yourself. Every piece of knowledge must have a single unambiguous authoritative representation within a system. So this is an example where the dry principle is violated by our unit tests. We have a test case class, canvas test. This is the class that holds our tests for a class that is named canvas. First, we're testing that a canvas has a width and a height. That is the test method that is shown from lines 8 to 14. Then we have another test. Test is initially black. And again, we create a canvas of the dimensions 10 by 20 with a background color of black 000. Then we have another test. Test a pixel can be written to a canvas, and once again we have a canvas of the dimension 10 by 20 with a background color of black 000. Of course, there are more test methods in that test case class than the 3 that I have shown. And chances are that in more than the 3 that I've shown here, we need a canvas of a certain dimension and with a certain background color. And it would be a good idea to not have that code duplicated. Even if it is just a single line of code that is duplicated in those 3 test methods, like 32, 18, and 10. Imagine you refactor at some point in the future your canvas object and fiddle with the argument order or add another parameter. Then in all the places where you create the canvas object for testing, you need to touch the code. And it doesn't really matter if you do that manually or if your IDE helps you with that through refactoring. It is a change that can be avoided and in my opinion should be avoided And here's one way of how you can avoid this. PHPUnit provides a mechanism in the form of template methods, methods that are automatically called by the test framework at well-defined points in the lifecycle of a test. For instance, there is setup, which is automatically called before each test method of a test case class. So we can declare a method setup where we create our canvas and we store that in the private property that is available to each of the test methods of that test case class. And because setup is executed before each test, we always have a fresh canvas object. There's an alternative way of using this template method that is automatically invoked before each test method. You can name that method any way you like. You can even have multiple methods if you want to more granularly decompose the setup of your test cases. The only thing that you need to do is tell PHPUnit that this is a method that needs to be executed before each test. And you do that right now with PHPUnit 9 and earlier using the before annotation. With the upcoming PHPUnit 10, provided that you are on PHP 8, you can also use PHP attributes for that, which is a much cleaner and robust syntax than annotations in code comments. What I personally prefer to do is something different though. I prefer to move the creation of an object, such as the canvas object in our example here, to a private method in my test case class and use that when I need that object. To me, I cannot really explain why, but to me, this leads to much more readable and clean test code. Yeah, and then in our test has width and height method, for instance, we use this. We call this canvas, get a fresh object, call this canvas again to test for the height. And you may call me paranoid, and I'm okay with that. I'm into testing and verifying things. So of course I am to some degree paranoid when it comes to coding. But I think there is value in testing both the width and the height method, which are close. They belong together because they define the dimension of our canvas. But I think there is value in testing them on separate, fresh canvas objects. Same goes for our test is initially black. We use this canvas method there, and sure enough, the same for a pixel can be written to a canvas. Sometimes you need to call the same test code with different data. And this is where data providers come into play. This is an example of that, once again, from the Ray Tracer project of mine. We're testing that the magnitude of a vector can be calculated. And we want to test that with different vectors and different magnitudes. So we parameterize our test method. Our test method now has the float parameters m, x, y, and z. M is the expected magnitude for a vector identified by the x, y, and z elements. And then we create a new vector using x, y, and z, calculate its magnitude, and assert that the result matches our expectation, which we got from the $m parameter. We use the data provider annotation to tell PHPUnit where the values for m, x, y, and z should come from. And that is a method that usually is in the same test case class as the test method that uses it, but it could also be in a different class. Such a data provider method returns, for instance, as shown in this example, an array that contains hard-coded values. But this could also be a generator. This could also be an iterator. The important thing is that if you're using an array, then that array should contain arrays, and each of those arrays leads to one execution of our test, and the elements of that array are mapped to the parameters matching their order. If you're using an iterator or a generator, then in each iteration step, an array should be yielded, and that array is treated in the very same way. This allows you, for instance, to completely decouple your test code from your test data. And the test data can, for instance, be in a CSV file, in an Excel spreadsheet document, in an XML file, what have you. And you implement a PHP iterator object that reads that file, parses that file, and yields the data, provides the data to the test. And this is something that is really helpful if you need to test code that has to be tested with many, many, many different variations of input. Of course, when you have something called dry, there has to be an opposite. And of course, the opposite of dry is wet. And wet stands for, and I'm not making this up, I kid you not, there is a website that lists a couple of dozen different explanations of what the acronym WET stands for. We edit terribly. We enjoy typing. Write everything twice. And so on and so forth. That is not really helpful. What is helpful is maybe something in between dry and wet. Sometimes dry is not really all that useful because there is a danger of drying your code so much that it becomes unreadable. I mean, we are doing refactorings like eliminating the code duplication in our test code using setup or before methods, as I showed earlier, to remove redundancy. And we are doing that to hopefully make the code easier to maintain and easier to read. But sometimes we are overdoing that. And helping us prevent that overdoing is DEMP, descriptive and meaningful phrases. Again, some principles favor readability over uniqueness. Yes, there is value in having something uniquely expressed in code only once. But if that uniqueness comes at the expense of readability, it may not be worth doing. So favor readability over uniqueness. Also, to eliminate duplication, we have to come up with abstractions. And sometimes those abstractions are not really helpful. We are only implementing those abstractions to get rid of the duplication, but there is no value in having the abstraction in and of itself. And it's hard to come up with a name for the thing that we abstracted out. And that should already tell us that there might be something going wrong. So if you have trouble coming up with an abstraction that eliminates the duplication, keep the duplication at least until you find a suitable abstraction. So favor duplication over the wrong abstraction. Yes, Sandy Metz said duplication is far cheaper than the wrong abstraction. Because imagine you make an abstraction like that does not feel right, but you do it anyway. And then a couple of days, weeks, months, years, maybe later, somebody needs to change that code, looks at it, and is confused because the abstraction doesn't make sense. So duplication is far cheaper than the wrong abstraction. So putting that into perspective, dry increases maintainability by isolating change risk to only those parts of the system that must change. And damp increases maintainability by reducing the time necessary to read and understand the code. And like with everything else in life and in software development, you need to find the right balance between those two extremes, or between those principles of dry and damp. So if we run the tests for our tuple class from the ray tracer project of mine using the --test docs CLI option, then we get an output like this. And this is, from my experience, a feature in PHPUnit that cannot be overrated enough, that cannot be valued highly enough, while at the same time it is a feature that almost nobody knows about. And the idea here is that we can think about testing not just as verifying that code works correctly, but we can also use it as executable specification and executable documentation. And whether we think about it as specification or documentation depends on the timing. If I'm doing test-driven development and use tests to guide my thinking, to understand the problem, slice the problem down into manageable steps, and to drive the development of the code that implements one step towards the solution, then those tests that I write during test-driven development serve as executable specification. Once I'm done implementing a functionality, a feature, whatever you want to call it, the perspective changes. It's no longer executable specification then, but it has become executable documentation. Because now you have something that you can execute that verifies that the code does what it is supposed to do, but it also documents what the code is supposed to do. And the only thing that this needs to work and provide you with a lot of benefit is that you consistently use meaningful names for your tests. Because the only thing that PHPUnit does here is look at the test class name tuple test. So it knows by convention that tuple test class is responsible for tuple. And it looks at your test methods, test a tuple with something is a point, and it replaces the underscores in our case here, in our example, in the test method name with spaces. Or if you follow camel case notation, then it will insert a space whenever there is a change between uppercase and lowercase. And that's it. There is no magic, it's just conventions. And this output is extremely helpful, and it's helpful in different scenarios. It's helpful if a developer needs to work with tuple. They can run the tests for tuple, look at this output, and get information about what tuple is responsible for and how tuple behaves in certain situations. They can then look at the test code that is responsible for one of these lines to be printed, and they will find an example for how the tuple object is used. This output is also useful if developers need to communicate with non-developers. For instance, a business analyst, a product owner, whatever title such a person holds in your organization. You can take this output and show it to an expert that is not a developer and say, hey, this output shows how we as the developers currently understand your requirements? Did we get something wrong? Is something missing? And you can have a discussion about that based on this output and not based on some vague things that you have somewhere in a ticket, for instance. This is really, really valuable. And the way that, for instance, some of the things in the output work, because I mentioned earlier, it just replaces underscore with spaces and uppercase and lowercase and so on. There is one additional trick that the test docs output looks at, and that is the test docs annotation, which allows us to parameterize the output for tests that are parameterized using data providers. So we can say something like, test docs annotation, the magnitude of vector xyz is calculated to be $magnitude, and then the values for each test data set that is executed for magnitude x, y, and z is replaced into our template that we defined using the test docs annotation. That is where this output comes from. For instance, the magnitude of vector 1.0, 0.0, 0.0 is calculated to be 1.0. So enough for now, at least, about how to write good test code and how we can make our test code better. What about finding code that is not yet tested? Well, of course, PHPUnit has had for a really long time had a feature called code coverage, which keeps track of which parts of your source code are executed while a particular test is running. And there are many different reports that you can generate from that, among them this HTML report. And this is the HTML-based code coverage report for the Ray Tracer project that I mentioned earlier. So we get an overview about directory structure and the files and so on, and we can use that to navigate to the individual file level. And on the individual file level, the lines are highlighted using a background color based on their code coverage. So a line can be white, no background color, like lines 1 to 24. That means those lines of code are not relevant at runtime. If at all, those lines are only relevant at compile time when PHP compiles your source code into bytecode for later execution. And these are things like whitespace, embedded HTML, class declarations, property declarations, method declarations, and so on. A line can be green, and the green line means this line of code is executable and it was executed by at least one test. And something that we do not see in this example is a line can be red, and red means a line is executable, it is relevant at runtime, it should probably be tested, very likely it needs to be tested, but at the moment there is not a single test that executes this line. If a line is green, you can hover over that line and get information about which tests are responsible for this line being green. We can make code coverage information more precise, provide more useful feedback to us if we use the covers annotation. This allows us to tell PHPUnit the tests of this class, tuple test, are responsible for the class tuple. If there is other code that is run, that is executed while a test of this class is run, ignore code coverage for that. Only keep code coverage information for what this test is interested in. So this prevents us from covering, marking something as tested with a test for tuple that is not tuple. That would be lying test, if you will, if tuple somehow also showed in the code coverage that we are testing matrix or array or canvas or whatever. You do not want that. You want code coverage information to be precise, and to have more precise code coverage information, you need to tell PHPUnit your intent, and this is what the covers annotation is about. You probably also want code coverage to be faster. And there has been done a lot of work in the last couple of years to make code coverage faster. It already was a lot faster than it originally was when Derek Rattan's originally implemented code coverage for Xdebug. I remember when I worked with Derek at Easy Systems back in 2006, it took about 10 to 12 hours to run the code coverage report for the test suite of the open source project Easy Components, where it only took like a couple of minutes to run the test suite without code coverage. And then he made it faster, and it only took like, I don't know, a factor 10 longer than running it without the tests. But more recently, a lot of work has been done to make it even faster. So for this benchmark, I'm not using the ray tracer, but the diff component that is used by PHPUnit to render a diff when, for instance, you are expecting that two arrays are the same, or that two objects are equal, or two long strings are equal, and you want to see the differences. That is where this component is used. And with PHP 8, plainly without any code coverage, those tests take 26 seconds. If we use Peacock, which is a new extension that only does code coverage, written by Joe Watkins, and it can only do line coverage, then those 26 seconds become 168 seconds. And it suddenly takes 3 GB of memory compared to 87 megabytes. If we do line coverage with Xdebug 3, it takes 234 seconds, and we do not really know how much memory it uses, because not PHP's memory manager is used. And if you are curious and have a lot of free time on your hand, and if you like chasing down long rabbit holes, then try to research how to really measure the memory consumption of a process on Linux. I gave up after a couple of hours, and I asked around people that know more than I about operating system and measuring things like that, and they said, don't go down that rabbit hole. It's not something that is really useful and easy to do. One thing that Xdebug can do that Peacock cannot do is path coverage. Not only looking at which lines of code are executed, but also which different branches and paths are actually taken. Because you can have test coverage that tells you all lines in my source code are covered by at least a single test, but that doesn't tell you whether you have really tested everything. You could be, for instance, do something like write all your code on the same line, and as soon as at least one statement on that line is executed, you have 100% code coverage, but that would be lying. So you need to go deeper and really understand the structure and the control flow of the code, and that is what path coverage is about. But path coverage is really expensive. Really, really makes it slow. And this is something that I do not think you want to do in continuous integration, for instance, but this is something that you do for a very specific piece of code, and only every once in a while to make sure, okay, am I covering all the different paths in this very important piece of code? It's also useful to put code coverage into perspective and not just look at the current state of code coverage. Do I have lines in my source code that are not yet covered by a test, but look at it how it changes over time. And change in general is an interesting thing to look at, which brings us to patch coverage. So you make a change to your software and you run your tests and you get code coverage. That is great. What would be even better is if you get information about, do I have tests that cover the lines that have changed? And this is what patch coverage is about. Also, you can put code coverage in correlation with other software metrics like change frequency. What are the areas of my code base that are changed most often? Usually, if something changes very often, you want to have good code coverage for that, to make sure that all those frequent changes do not break something in an unexpected way. Patch coverage is something that PHPUnit does not do, and it doesn't do it because I do not think that it belongs into PHPUnit. It belongs into a separate tool. I created such a separate tool, which is called PHPCOV. You can also find that on GitHub, but also third-party integrations like CodeCoff, which is a SaaS solution for visualizing code coverage information from PHPUnit, for instance. You can add that to your GitHub project, for instance, or to your GitLab project, and it will look at changes made to the repository and visualize the coverage diff is what they call it, what I called patch coverage earlier. And in this case, 97.14% of the lines that were changed by a commit have been tested. And with regard to change frequency, we first need to figure out change frequency. That is rather easy. There is a Git effort, which is a plugin for Git, and you just run that on your Git repository, and it will calculate a bit, gather some data, crunch some data, and then it will come back to you with a list of which are the source code files that are changed the most often. And then you can look at your code coverage report and see, do I have good code coverage for the classes, for the objects, for the code that is changed the most often? PHPUnit also has some functionality to find risky tests that are risky because they give you a false sense of security. So for instance, you can turn on that you want to be strict about the covers annotation that I mentioned earlier. So if you have a test that has a covers annotation and executes code that is not listed using the covers annotation, that test will be marked risky. You can have tests marked as risky when they produce output, because usually you do not want tests to print to the console. You can configure PHPUnit to not only warn about risky tests, but still mark the result as successful for CI. No, you can instruct PHPUnit to fail on risky tests and exit with a shell code that signals a continuous integration server, for instance, that this is a failed run. You can do the same for warnings. You can instruct PHPUnit in the XML configuration file to enforce that every test case class has at least one covers annotation. You can use PHPUnit to find tests that are codependent, that depend on each other. So for instance, if you have a test that manipulates a global variable, and then you have a different test that also does something with the global variable, and you run them and everything is fine, but there is a problem hidden under the surface that is not visible here, but it becomes visible if you run the tests in a random order, and then the second test suddenly fails because it's executed before the test that sets the variable in the global scope that it relies on. This is how you can uncover something like that. You can also tell PHPUnit to make a backup of all global and super global variables before each test and restore that after the test has concluded. This is also a great way of recognizing such codependency between tests. Let's talk briefly to wrap it up about organizing your test suite. You can have more than one test suite that you configure in your XML configuration file. This is something that I usually do in a project. I have 3 top-level categories: unit, integration, and end-to-end. And you can group them separately and give them names like unit, integration, and end-to-end. And what this allows you to do is run PHPUnit only for your unit tests, and only for your integration tests, and only for your end-to-end tests. And then you can set up a CI pipeline that first only runs the unit tests. And if those tests have succeeded, then and only then it runs the test suite that contains larger tests that are slower to execute. You can, of course, have a more fine-grained test organization using the group annotation. For instance, you may want to tag tests that you want to have in test docs output that you present to non-developers tagged into a group named business. You can also use the ticket annotation as an alias for group to make it clear, hey, this test refers to Jira ticket number 3. There are 3 special annotations in PHPUnit: small, medium, and large, that are aliases for group, small, group, medium, group, large. And PHPUnit can do additional risky test checks based on those special properties that you annotate to a test. So a small test needs to be really quick, and it's not allowed to perform I/O and so on. And you can turn on additional risky test checks for that. You can list the groups that are available in your test suite, and you can select which test group to run using --group. There's also --exclude group, for instance. Maybe you want to run all the tests except for those that are annotated to be slow or annotated to touch the database, and so on and so forth. To wrap up, do not write code. Code in the original meaning of the word as something that is very cryptic. Write clean, understandable software, and that also pertains to tests. Write programs that you still understand tomorrow, and programs includes your tests. Write programs that your team understands today, which is just a different way of saying the thing that I said before. But remember that your job is not to write a program. Your job is to understand and solve a problem. And I can only very subjectively talk about my experience here. In my experience, tests help me with understanding a problem, which is why I really enjoy test-driven development. Tests help me understand the problem, help me slice a bigger problem in a sequence of smaller problems, and guide me on the way, making each individual step towards the solution. But tests can only help with understanding a problem, and they themselves can be understood. And that is only the case if you have readable and maintainable test code. And I hope that you not only enjoyed this presentation, but also learned a thing or two how you can write better tests. If you need help with that, I can help you with your tests. Contact me. One of the things that I do as a consultant is work with teams on improving their test suite. Get them started with using PHPUnit, get them on a way to do test-driven development, help them find problems in their test suite, be it coding-related things or organizational things, or setting up better CI pipelines. If it has to do with testing in PHP applications, I can help you. Contact me. And thank you for your attention. Thank you for attending my presentation, and I wish you a nice rest of the conference. Bye-bye.
Thank you, Sebastian, for your talk. There are quite a lot of questions, and you have already managed to answer some of them. Maybe you want to highlight something from the questions in person, like saying that, because not all our listeners are reading the chat. So maybe we can like read and you can answer some of the questions which you think are the most interesting.
Sure. So hi, first of all, and thanks for having me. I can't really read the questions at the moment. So if you have questions, can you read them out so that I can answer them?
Yeah, sure. I will read the ones I like the most.
Yep,
so the
thank you.
question is, how about including the database into the testing, and where should be made pre-flight DB preparations?
So when it comes to testing database interaction, there is one fundamental problem that you need to keep in mind and you need to take care of, and that is getting the database into a known good state, a state of the data that you need to perform your test. Like for if you want to test something that relates to data from one particular table, then of course that table needs to be brought into a state where it has the data that the test is interested in. And everything that has to do with the database is usually slow. So I can understand the desire to only do the database or the test database setup once before the first test. And that would be fine if there were not troubles involved. Trouble in the form of one test runs and does something with the data, and then the test fails, and then the next test runs and finds the data in an invalid state, and suddenly you have two failing tests, and then the next test comes along, and so on and so forth. And before you know it, you have dozens or hundreds of tests failing, and you do not really know why these tests are failing. Are they all failing because everything that these tests want to test is broken? Or are these tests failing because one test did not clean up after itself, and all the other tests are not actually failing because there is something broken in the code, but it's just because the test database is not in a valid state. And like with a lot of other things, you have to weigh two priorities against each other. You have a conflict of interest there, if you will. On the one hand, you want to have reliable tests. You want to be certain that if your tests are all successful, that everything is good. You want to be certain that when a test fails, that something in the implementation of the aspect of your software that is verified by this test is broken. You do not want to have a situation where you are uncertain and unsure what the test result means. On the other hand, you want to be able to execute your tests quickly. So you need to find the right balance in there. And there are different approaches to how to deal with that. Like I mentioned earlier, you could only set up your test database once before the first test, but you could, and I would recommend to do that for operations that are really critical. Set up the database for each test. That way you are sure that if something breaks, it has nothing to do with an invalid state of the database because a previous test has failed. In general, you probably want to strike a balance between those two extremes, and that could be setting up the test database once for all the tests of a single test case class, running the test setup before the first test of that test case class. But and that's probably the last thing that I would like to say on the topic right now, is there are mechanisms, there are techniques that you can use to make having a high level of isolation, like having a fresh database for each test, less resource intensive. And that is something that can be achieved in a lot of situations with containers. Have a container image that has the database server in a state where the server is already running, where the database has the data that you need for your test, and you start the container, and starting a container is usually really quick. And that once the container is started, it is in the state where the test can interact with it. And at the end of the test, you throw away the container. And you do not need to do any cleanup because it's automatically cleaned up, because when you start the database container image again, it will be in the very same state. So there's nothing to clean up. And I hope that answered that question.
Yes, it's a very detailed answer on the question. I have a bit of addition to the question. I've heard once about the idea of wrapping the test in the database transaction. So you put a begin somewhere in setup and roll back after a teardown. Do you believe that's a good idea?
It is a good idea. The problem with that idea is that it is not always possible to implement that idea, because there are databases or versions of database servers or configurations for certain databases at specific versions where you do not have support for nested transactions. So for instance, if you want to test a piece of code that talks to the database, and that piece of code that you're interested in that uses transactions itself, which it should, because using transactions is a good thing, then that will not work. Because if your database does not support nested transactions, those subsequent begin transaction calls are ignored, and your code will be run differently in testing than it is run in production, because in testing you have this additional transaction layer, and that is usually something that you do want to avoid. You do not want to run your code differently than you use it in production for testing. Related to that is a technique that a lot of people use, which I do not like at all, which is, okay, I use in production MySQL or MariaDB or Postgres or whatever, but for testing, I use SQLite in memory. Now, don't get me wrong, SQLite is a brilliant piece of technology. It's a great database, and I really like to use it for specific use cases. But one of its use cases is not replace, emulate a client-server-based database management system. So if you use MySQL in production and you use SQLite for your tests, when your tests pass, great, that's nice. You have just verified that your software works with SQLite. But how valuable is that piece of information when in production you use MySQL or MariaDB? So I get the idea that people want to run their database interaction tests faster, and I get that they can run them faster using SQLite in memory, but that comes at the cost of reliability and value in the result of the test.
Okay, thank you. That's a really detailed explanation on the idea of having a commit and begin and rollback in your test case. And another question is, what about reflection or dependency injection container in tests over mocking? What about using reflection or dependency injection container in tests over mocking?
I don't really understand the questions. Sorry.
I'm not sure I guess it's the question about can you use dependency injection container in your test if you're not testing the dependency injection container as well?
My answer would be sure, why not? But there is no magic in PHPUnit that would automatically create those stubs and mocks for you and wire them up with the system under test. I know that there are test frameworks out there that do that. I do not like such magic. I like magic in my fantasy literature, in TV shows, and in movies, and in games. But magic in code, I'm not a friend of that. Sorry.
Okay, and the last question for this Q&A session would be, should my test case classes be final?
PHPUnit doesn't really care about whether or not you declare them final. I personally declare my test case classes to be final to make my intent explicit that this is a test case class that I do not intend to extend. To make it explicit that this is not a test case class that is designed to be extended, and in general, not talking about testing for a second, I do not think that there is much value in having a class that is not declared to be either abstract or final. And in all my projects, I either have abstract classes or final classes, but not the regular class. Because if there is not final or abstract as a keyword, I find that confusing, because just by looking at the declaration, I do not know what the intent is here. Is this something that is ready to be used? Is this something that should be used in a different way? Do I have to extend it? Should I extend it? Is it okay to extend it? So I try to program defensively and avoid as many problems that I can avoid in the first place. And to me, one of those things is to never use the class keyword without also using final or abstract.
The background for this question was actually a talk that we had today from one of our speakers about the misunderstanding of final keyword in PHP and how it protects and what it protects from. So people are interested in how should they use final after the talk. Okay, so we are thankful for the talk you gave us in the Q&A session.